Here we've been asked to sketch the graphs of the following by using rules of translations and reflections. So we've learned in earlier sections how to translate and how to reflect basic graphs. In this particular set of material, our basic graph is going to end up being an exponential function, which essentially has a horizontal asymptote along your x-axis, and the basic shape looks like this. You have a y-intercept of 0, 1. Okay, each one of these are exponential functions, and so they will follow that shape, except for any kind of reflections or translations that happen. For this first example, we see that there's a -4. The -4 occurs outside the function, so that means that we're going to go down 4 units. So what I would do is take my basic shape, and what I would translate down 4 units would actually be the horizontal asymptote. So I go down 1, 2, 3, 4, and then create a dotted line going through -4. And then this would be where my new horizontal asymptote is for this particular function. Now, notice that in the basic shape, the y-intercept always happens 1 unit above the horizontal asymptote. And so here, my new y-intercept would occur at 0, -3. Okay, the basic shape stays the same, close on the left side here, and then curving up and getting large there. Okay, for the next example over, we notice there's actually 2 things occurring. There's a negative that's applied to the x value. What that will do is it will flip it over the y-axis. So this is a reflection over the y-axis. And then we notice that there is a +2 on the outside of the function that would shift it up 2. Okay, any kind of reflections need to be done first. Okay, think of it this way, and I'm actually going to do this in 2 steps. If you took your basic shape, which is this, and you reflected it over the y-axis, it would end up being something like this. Okay, so think of that as your reflection. Then, if I was going to shift it up 2 units, instead of my horizontal asymptote being along the x-axis, it would be shifted up 2 units. And so there, we're going to go up 2, put the dotted line, that's the horizontal asymptote there, that would be at y is 2. And then we can see from my reflection that my graph would be getting close to that y equals 2 line on the right side, and then growing without bound on the left side. We would also want to label our new y-intercept. The new y-intercept is also going to be 1 unit above wherever my horizontal asymptote is, and so in this case that new intercept would be 0, 3. Next example down, we have the -3 to the x power. Notice that there's a negative in front of the 3. What that will do is that will flip or reflect over the x-axis. Okay, so our basic shape, we would have a horizontal asymptote along the x-axis at y is 0. If we reflect our graph over the x-axis, that's not going to change. Reflecting over the x-axis will cause my graph now to have a y-intercept below at the ordered pair 0, -1. I still get close on this left-hand side, and then I go decreasing without bound on the right-hand side. Finally, we have f of x equals e to the x plus 1. Notice that the +1 is a change to the x value, which is a change on the inside of the function. This means that I would shift my function left 1 unit. It's always opposite of whatever the sign is in that case. So on here, if I shift it to the left, my horizontal asymptote doesn't go anywhere, it's still y is 0. What the left 1 unit will do is it will move the point that was originally my y-intercept. My y-intercept was originally at the ordered pair 0, 1. Now it will take that ordered pair and shift it to the left 1 unit. So now I have a new ordered pair. It's at negative 1, 1. And you also see we're going to have a new y-intercept. Okay, if we wanted to evaluate and find that y-intercept, we could. Right here though, all I need is a sketch. And what I wanted you to do if you're shifting left or right is I want you just to indicate where the old y-intercept would end up. And so this sketch is okay for testing purposes.